Hello everyone. Today we're going to be going over polar graph sketching, and in this specific video we're just going to be covering the rules and steps to sketching polar curves given a function r is equals to r theta. And sometimes r can be thought of as a vector. So to help us today, before we start, I've drawn our polar plane on the right to sort of give us an idea of where we're going to be sketching this polar curve. So like I just said, right now this video is just going to explain the simple steps that you take before you start sketching your curves given a specific function r is equals to r phi theta. So let's just start with the rules, and we're going to try to work on that. And let's remember that our theta here is basically the angle as we move across the plane. So that's going to be very important. That's going to be our theta. And r is the extension from the center, or you can call it the origin, or sometimes called the pole. So r is just basically the length of any vector extending from the origin or the center of our polar plane. Okay, so let's just start and go quickly over the rules, and maybe in the next video I will go over an example following the rules and steps that will have been outlined here. So the rules are very straightforward and simple. I think we just have three. The first one is that r must always be greater or equals to 0, and this should be obvious because r represents the length, and in the real world, outside of imaginings, or you can imagine it as well, length can never be negative. It can go the other way, but it will still be positive length. You cannot have negative length. So that's why for rule 1, r must always be positive. This means that if we were to imagine it for what type of function, say for example, y is equals to, sorry, not y, apologies for that, r is equals to sine theta, terrible theta, r is equals to sine theta, r must be greater or equals to 0. So for points, say after theta is equals to pi over there, we cannot have r be negative. We cannot have our r to be negative here. It has to be positive. So in that case, we'll have to move this function up here so that our r is always positive. And this is going to play an important role, and you're going to need to know it before you start sketching, and it's going to help in most functions that may look a bit obscure and strange. So let's move on to the second rule. Sorry about that. Okay, the second rule just says the relationship between your rectangular plane and your polar plane is basically obvious from observation. This means that we can look at the xy plane. This is going to be our xy plane, and then we can be able to draw from there our r theta plane, which is our polar plane. And this is going to play also another important role when we start sketching. I hope that will be obvious. And the last important rule is going to be the fact that for trig functions, theta is equals to theta plus 2k pi. That means they are periodic every 2k pi, where k is an integer, positive or negative whole number. So that's going to play another important role. So you notice after for cos theta, or say for sine theta, it change after 2 pi, which is the period for cos and sine, we get a sort of repetition. It also applies for 10, although 10 tends to be a bit more funny. And then we're going to notice that's going to play a very important role as well later on. So now for the steps of how to go about sketching this. Now step 1 is you must draw r theta as a function of x. That means you let r equals to y and theta equals to x. Simple as that. And then when you have a function y of x, then you draw it on your y-x axis or xy axis, and then you're gonna see a sort of relationship which we're gonna demonstrate in the second step. Okay, so the second step is we have to break down our x-axis into the 4 quadrants in the polar region. Apologize for writing slow. I wish I was a bit more faster. Okay, so this means that, as I stated before, our polar region starts from 0, it goes pi over 2, and 3 pi, oh no, sorry, it's not 3 pi over 2, definitely not 3 pi over 2. This is going to be pi, and this is going to be 3 pi over 2, and that's going to be 2 pi again. So that's where it basically starts repeating. And this is our polar coordinate. But notice for our xy coordinate, if we treat x as theta, that we're going to get pi over 2 here. That's our 0. And this is going to be our pi. And this is going to be 3 pi over 2. And that's going to be 2 pi. Notice now that this can be directly explained with the other function. So say for example, this quadrant here, it's basically this whole region here separated by this dotted line. So this would be our first quadrant, and then our second quadrant, it's all this region here, which can be explained by here because it's between pi over 2 and pi, and here it's pi over 2 and pi. So that's going to play an important role to helping us draw these polar curves really quickly. And then the other one, I think I seem to be running out of color here. Okay, I'm just going to use black. And then this other one is going to be this one here, and it's going to match with that one. And I think we can afford to use blue. I hope no one minds. And blue would be this one here. So there's a direct relationship, and this is going to play a very, very important role when we start sketching. And lastly, for the final rule, we have to draw r theta. Noticing after breaking down here, so breaking our x-axis into those 4 quadrants, it's going to help us to sketch our polar curve r as a function of theta. So that's that for now. Hopefully I'll be making a video, and we're going to be doing an example next over following these 3 essential steps and the rules mentioned above. I think the most important one is rule 1, and the other ones, and they're just going to help us maintain a sort of direction and order to what we're going to be doing. I think I'll stop it here.